Selamat pagi Bapak Ibu. Terima kasih atas kehadiran Bapak Ibu pada acara webinar Indonesia's Biorefinery Future Outlook and Introduction of Technical Solutions. Perkenalkan, saya Adisti Gesani. Hari ini saya akan memandu jalannya webinar hari ini.
皆様こんにちは。本日、インドネシアにおけるバイオリファイナリーの将来、展望と最新技術の紹介のウェビナーにご参加いただきまして誠にありがとうございます。はじめまして、本日の司会を務めさせていただきますアリスティと申します。そして私は通訳のティサーと申します。よろしくお願いいたします。
Indonesia's Biorefinery Future Outlook and Introduction of Technical Solutions merupakan webinar yang diselenggarakan sebagai bentuk kolaborasi antara The New Energy and Industrial Development Organization NIDO yang merupakan badan pemerintah yang bergerak di bidang research and development sektor energi di Jepang bersama dengan Badan Pengkajian dan Penerapan Teknologi BPPT yang merupakan lembaga di bawah koordinasi Kementerian Riset dan Teknologi yang bertugas melakukan pengkajian dan penerapan teknologi di Indonesia.
インドネシアにおけるバイオリファイナリーの将来展望と最新技術の紹介のウェビナーは、国立研究開発法人新エネルギー産業技術総合開発機構ネドバンコク事務所ジャカルタオフィスとインドネシアの技術評価応用庁 BPPT と共同で開催をいたします。技術評価応用庁は研究技術所参加の機関でインドネシアの技術の研究と応用を行っている機関です。
Untuk memastikan acara webinar ini dapat berjalan dengan lancar, terdapat beberapa terms and condition yang wajib kita patuhi bersama. Antara lain, selama acara berlangsung secara otomatis, Zoom semua peserta akan di-set menjadi mute dan kamera akan nonaktif.
このウェビナーをスムーズに実行するためにはいくつかの説明事項があります。1、ウェビナー中、すべての参加者の Zoom は自動的にミュートに設定され、カメラもオフになります。
Kedua, peserta tidak dapat memberikan komentar atau menyampaikan pertanyaan terkait materi yang disampaikan secara lisan. Peserta hanya diperkenankan untuk memberikan komentar atau pertanyaan terkait materi yang disampaikan secara tertulis dalam kolom Q&A yang dapat dilakukan sejak presentasi mulai berlangsung.
2、参加者は口頭でのコメントや質問することがございませんが、質問等がございましたら、プレゼンテーション開始後、Q&A の欄にインドネシア語や英語で書いていただくことは可能です。
Presentasi akan dilakukan dalam bahasa Inggris, penyampaian lainnya akan dilakukan dalam bahasa Indonesia dan bahasa Jepang yang diterjemahkan ke dalam bahasa Indonesia oleh penerjemah secara beriringan.
プレゼンテーションは英語で行われますが、それ以外、インドネシア語と日本語でお話しした場合は、逐次通訳が入ります。
Pada sesi tanya jawab atau Q&A, moderator akan memilih pertanyaan yang sudah diajukan pada kolom Q&A untuk dijawab langsung oleh speaker dalam bahasa Jepang dan diterjemahkan oleh penerjemah ke dalam bahasa Indonesia secara beriringan.
Q&A の時は、モデレーターがいくつかの質問を選んで、スピーカーは日本語でまたはインドネシア語で回答する場合は、逐次通訳が入ります。
Baiklah Bapak Ibu, kita akan mulai acara puncak kita, yaitu presentasi dari para pembicara yang akan dipandu oleh Bapak Dr. Hans Saputra sebagai moderator. Bapak Dr. Hans Saputra sendiri adalah Director of Center for Energy Resource and Chemical Industry Technology at Agency for the Assessment and Application of Technology. Kepada Bapak Dr. Hans Saputra, kami persilahkan untuk memandu presentasi dan diskusi.
さて、ご参加の皆様、ここからはプレゼンテーションセッションに移りたいと思います。本日のモデレーターはヘンス・サプトラ様です。ヘンス・サプトラ様は技術評価応用庁エネルギー資源科学産業技術センターの局長として務めております。それではヘンス・サプトラ様、どうぞ。
Okay, thank you very much. Hello everybody and welcome to BPPT and NIDO Biorefinery webinar series. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi dan salam sejahtera untuk kita semua. Konnichiwa. The Honorable Chairman of the Agency for the Assessment and Application of Technology, Republic of Indonesia, the Honorable Chief Representative NIDO Asia Representative Office, Ms. Yurugi Yoshiko, the Honorable Deputy Chairperson BPPT for Information, Energy and Material Technology, the Honorable all of the speaker, Mr. KAKESHITA Hiroshi from KAKESHITA Corporation, and Mr. Obie Farobie from IPB University, Bogor Agriculture Institute. Ladies and gentlemen, all of the participants, Alhamdulillah, thanks and gratitude to Allah Subhanahu wa Ta'ala that with His permission we can attend the webinar series, namely Indonesia Biorefinery Future Outlook and Introduction of Technical Solutions, which was held in collaboration BPPT with NIDO from 14 to 2 days, 17 December 2020, for 4 days. And today is the last day of this webinar series. When the first day, we have discussed about the government policy and the latest trend in the field of biomass. Then the second day talk about the introduction of the latest biorefinery solutions, especially for gas and biogas. And yesterday we have talked about the technology which related with upstream sector, such as sustainable plantation, tissue culture, and so on. Today, we will discuss about the downstream technology which related with the latest biorefinery solutions. It is the most interesting topic that we want to get some information about the knowledge and experiences. Of course, the highest value lesson learned will be set for you. What is it? The high value added technology. I will invite two famous and competent speakers in this field, Mr. KAKESHITA Hiroshi from KAKESHITA Corporation and Mr. Obie Farobie from IPB University. Okay, once again, before we begin the presentation, let me read the rule again, that each of the speaker will give the presentation about 25 minutes in English. First speaker, 25 minutes, and second speaker, 25 minutes. Then we continue with discussion or question and answer. We will let the question and answer in Bahasa Indonesia and will translate in Japanese. So the audience can ask in Bahasa Indonesia or English. Please write your question at the chat room or raise your hand. Then the host will give the time, let you to ask the question directly to the speaker. Okay, for the first speaker, Mr. KAKESHITA Hiroshi, he is a senior manager at KAKESHITA Corporation. The brief overview of the company is as you can see in the screen. The KAKESHITA Group develops its consumer and chemical products in Japan. It is a well-known company, and some of us is the consumers as well. And this company have developed the cellulosic biomass sacharifying enzyme for sacharifying non-food resources. And KAKESHITA Corporation can provide you with the technology to cellulose in on-site enzyme production. Mr. KAKESHITA Hiroshi will give the presentation with the title Biomass Saccharification Technologies for Producing High Value Added Substances. Okay, now we continue with the presentation about 25 minutes. Mr. KAKESHITA Hiroshi, time and screen is yours.
Okay, thank you. Thank you for your Thank you for your introduction. Can you hear me? Okay. Can you see my slide?
Yes. Yes.
Thank you. Hello everyone, this is Hiroshi KAKESHITA from KAKESHITA Corporation in Japan. Thank you for your introduction. I'm the Senior Manager at Biological Science Research, and I'm in charge of microbial engineering. I would like to thank NEDO and BPPT for organization this seminar and for giving me the opportunity to speak here. Today, I will discuss about the saccharification enzyme technology required for biomass utilization. At first, this is a great opportunity to introduce you to our company. After that, I would like to introduce today's topics, the saccharification enzyme technology. It contains background and motivation and cow saccharification enzyme and application for our technology system. Well, first we would like to introduce our company, KAO Corporation. This slide shows company outline. KAO was founded over 130 years ago in 1887. Our annual sales fiscal year 2019 were 1,500 billion yen, and our operating income was to 117 billion yen. About 33,000 people work for KAO. This included personnel in group companies and outside Japan. In this slide, KAO started as a small company selling imported soap and general goods. When KAO was founded, Japanese-made soap was poor quality, and imported facial soap was very expensive. KAO Sekken was born from company founder Tomiro Nagase's strong desire to make quality facial soap available to ordinary people at affordable price. KAO Sekken name has an interesting origin. In the 1770s, facial soap was called Kao Arai, Japanese Kao Arai, which literally name means face wash. Also, the character that difference the Kao in Kao Sekken has the same production as the Japanese word for face. Eventually, Kao was adapted to the current company name. This slide shows sales composition by segment. Our consumer products business consists of cosmetic, skincare and haircare, human healthcare, and fabric and home care. Or 83% of KAO's consolidated sales for fiscal year 2019 was generated by our customer product business. The cosmetic business included skincare, brands such as Est, Sofina, and Cure. The skincare and haircare business included skin products like Biorefinery body wash and hair care products like Essential. Human healthcare business included Mary's Baby Disappear, Bus Additives, and Healthy Functional Beverage. The fabric home care business included Attack Laundry Detergent and Magically Household Cleaning. We deliver familiar products that people use daily. Our goal is to make each and every day filled with joy by delivery. The remaining 60% of KAO's consolidated sales comes from industrial products in the chemical business. The chemical business offers an expansive array of products globally, such as Oreo chemicals manufactured from nature fat and oil, performance chemicals such as surfactant, and specialty chemicals such as toners and toner binder. Next, it shows the global expansion of the business. KAO's product services are offered to customers in almost 100 countries and regions around the world, including Asia, of course, including Indonesia, and America, Europe, as well as in Japan. Committed to enrich the lives of people around the world, KAO listens closely to consumers in order to develop products to meet their needs in every life. Next, I would like to talk about the Kirei lifestyle plan and Kao's ESG strategy. The Japanese word kirei means beautiful or clean, not only on the outside but also on the inside. For us at Kao, kirei is very we want to bring to everyday life with our brands, products, and service. Kao strives to enrich the life of consumers around the world. Therefore, our ESG strategy is designed to serve people's needs, behaviors, and desire to live sustainable lifestyle that contribute to sustainable world. We call the Kirei lifestyle and we call the vision, commitment, and action that contributes to that lifestyle, the Kirei lifestyle plan. Kao will strive to create long-lasting impact to society through the Kirei lifestyle plan. So, Kao believes that addressing ESG-related issue is essential for long-term corporate growth and will also contribute to the certain of a sustainable society. Going forward, the Kao Group will continue to make active efforts to be a company that is supported the trusted group. Now, let's start today's topic, saccharification enzyme. In this previous section, we introduce you to our products, household clothing detergent trade name Attack. Since its launch, Attack has been compounded with enzymes. It has been independently developed and manufactured in-house. So we have continued to develop the enzyme. In addition, we have a manufacturing technology that has been cultivated over many years. Thus, we had asset with recent to cellulose. Therefore, as a business that requires cellulose, we focused on bioethanol, especially cellulosic ethanol in second generation biofuels. As of 2016, the cellulosic ethanol market has been declining, but global renew has continued to grow. In particular, saccharification enzyme range are considered to be costly. Many users considering 2G ethanol production are looking for higher performance and cheaper biomass saccharification enzyme. Therefore, we decided to take on the challenge of industrial production of Kao's original saccharification enzyme. We participated in the NEDO project, development of efficient element technology for biofuel production from fiscal year 2030 to 2060. NEDO promoted the technological development of each process for bioethanol production using non-edible biomass as a raw material and aimed at demonstrating on a pilot scale. Our mission was to develop a production technology for useful saccharification enzyme. In this project, we improved the saccharification enzyme performance and developed a saccharification enzyme production technology. In this project, enzyme production was designed to be carried out on-site. Here, we compare on-site and off-site manufacturing method. In this case of purchasing a saccharification enzyme, the enzyme is produced off-site and delivered as a product. Off-site production involves enzyme production using microorganisms, following by process such as cell removal, enzyme purification, concentration, and compounding to produce the final product. Enzymes produced overseas and delivered to manufacturing plants, BSC and road transportation. On the other hand, for on-site production, the on-site On-site process shown in red frame, optional manufacturing process and transportation are not required. In addition, also investment in manufacturing equipment is required, but utility can be unified because the equipment is in one place. I will now introduce technology based on the NEDO project. We selected trichoderma as the host to produce saccharification enzyme. Trichoderma is known for its high production of cellulose in cellulosic medium. Enzymes such as Farobie hydrolase, CBH, and glucanase, EG, and beta-glucosidase, BGL, are required to saccharification cellulose contained in non-edible biomass. In addition, enzymes such as xylanase and xylosidase are required for the decomposition of hemicellulose. Trichoderma can produce many types of enzymes at once. Therefore, it has been used as a saccharified enzyme producing bacterium for a long time. However, it is not sufficient activity in biomass saccharification. It is known that an effective solution needs to have an effective enzyme component. Therefore, we must develop them. This slide shows R&D item in NEDO project. R&D item 1, Department of High Performance Saccharification Enzyme. High performance enzyme component were developed to improve enzyme component and optimize enzyme complex for several pretreatment of biomass. Item 2, construction of industrial production strain for saccharification enzyme. The high performance saccharification enzyme was produced by recombinant mutant strain that were constructed by the introduction of high performance enzyme components. In addition, industrial production strain will be designed to overproduce enzyme and adjusted to use a low-cost carbon source. Item 3, development of large-scale and low-cost production of saccharification enzyme by trichoderma ricei. Fermentation process for the production of saccharification enzyme were examined using the pilot scale. For ethanol production, a commercial scale cellulose production system will be established. First, R&D item 1, we found a penicillium strain SPF532 in an in-house library. This strain produced the most effective enzyme to promote saccharification of alkali pretreated bagasse. Biomass degrading enzyme from the strain F532 were fractioned and analyzed, and we identified a novel xylanase named PSP Xyn10. This xylanase has a cellulose binding region at the C-terminus. Moreover, the CBM1 domain of PSP Xyn10 contributes to the enhancement of the saccharification efficiency. This figure shows the effect of adding xylanase. The base enzyme is secreted from T-ricei, and xylanase was added to the base enzyme. As a result, the saccharification activity increased. Consequently, we succeed in discovering an enzyme that improves saccharification performance. Next, we need a host with higher enzyme productivity. Therefore, we selected the strain capable of enzyme production in the presence of glucose from the mutant library. The mutant library was created using an ion beam as a mutagen. As a result, one strain was selected from among 10,000 mutant strains. This strain was more productivity than parent strain. In addition, the present strain exhibit a significantly reduced cellulose production in the glucose cellulose mixed medium. Moreover, the mutant strain was capable of production of cellulose if glucose was present. As a result, a new host strain could be created. Shown here is the performance evaluation developed saccharification enzyme. A production strain was constructed by introducing a novel xylanase or a modified enzyme into the selected trichoderma mutant strain. The strain was cultivated to produce enzyme, a prototype 1, 2. As a result, the amount of prototype saccharification enzyme used was reduced compared to the legend enzyme product at that time. Finally, item 3, we aim to develop a commercial scale culture technique using the production strain. For step 1, cultivation using a small scale jar fermenter in the lab was done. Next step 2, involved culturing on a pilot scale. At this stage, we identified the problem for scaling up. As a result, in step 3, culturing on a commercial scale at the same level as that on the laboratory and pilot scale was a success. Based on the plan of the NEDO project, the cost benefit of on-site manufacturing based on the finished commercial scale manufacturing technology was than estimated. For on-site production, enzyme purification and concentration, manufacturing process, and transportation costs are not required, and saccharification enzyme was improved yield. Results show that the cost of on-site manufacturing can be reduced by 60% compared to that of off-site manufacturing. The cost reduction effects depend on the difference in saccharification properties associated with the substrate and the scale of production. Therefore, although there are differences in effective on-site manufacturing can differently reduce the cost of the enzyme. Next, I will introduce an example using on-site technology. The purpose of providing enzyme through on-site manufacturing is to reduce enzyme cost. To reduce the enzyme cost, it is better to produce a large volume. Therefore, it is desirable to build multiple biorefinery plants near the enzyme plant. With the goal of reducing CO2 emission in 2030, we hope to create an environment in which we can invest in the production of high-volume 2G ethanol and biochemicals. We strongly expect the government to support second-generation bioethanol production and chemical for better sustainable future. We hope that biorefinery complex will be built in Indonesia in the future. At that time, we would be very happy if our technology was used. Finally, today's summary. Conclusion. We succeed in developing a new saccharification enzyme and constructing an enzyme production host, and successful scale-up for industrial production. Finally, succeed in demonstrating cost cost savings through on-site production. In future, on-site production technology can be provided to users. Therefore, please let me know if you require anything further. Thank you, attendance. Thank you.
Okay, thank you very much. Thank you very much, Mr. KAKESHITA Hiroshi, for the nice presentation. From here, I see some of the audience want to ask the question or give the comment, but please keep the question for a while. For those of you just joining us, welcome to BPPT and NIDO Biorefinery webinar series. And thank you very much for your attending. Okay, the second presentation will present by Mr. Obie Farobie. He is the lecturer at IPB University and researcher at the Surfactant and Bioenergy Center, SBRC, IPB University. As we know, IPB University is a higher education institution that produces innovations with nationally and internationally acknowledged quality. For 10 years straight, from 2008 until 2018, APB has the most innovation compared to other university in Indonesia, based on a prize from Business Innovation Center, Ministry of Research, Technology, and Higher Education of Indonesia in Indonesia's most prospective innovation. Mr. Obie Farobie will give the presentation with the title Bio-based chemical from biomass. Wow, we know that we have abundance of biomass, but we have not optimally utilized this potential biomass. Some of the researchers and engineers in BPPT are still conducting the assessment and application of this technology as well. Hopefully, they can make collaboration and synergy in the future. Okay, same as previous presentations, the time is about 25 minutes. Mr. Obie Farobie, time and screen is yours.
All right, thank you very much, Pa Hans, for the introduction. Let me share my screen. Can you see my screen?
Yes.
All right. Okay, Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. I am Obie Farobie from Surfactant and Bioenergy Research Center, IPB University. Ohayo gozaimasu. Bogor no Gyodaigaku no Obie Farobie to moushimasu. Yoroshiku onegaishimasu. Well, without further ado, I would like to present my presentation entitled Bio-based chemicals from biomass. So before we are going further, I would like to briefly introduce about the Surfactant and Bioenergy Research Center. This is the center under IPB University, located in Bogor. It is just close to BPPT. It takes approximately 1 hour by car. And then the vision of the center is to become internationally recognized center of excellence on surfactant and bioenergy based on sustainable agricultural resources. As mentioned by Pak Hans, that we have a lot of the biomass. And the center was established in 2004 as the name of the Surfactant Research and Development Center. And then in 2006, the center was changed the name from SDRC to SBRC, Surfactant and Bioenergy Research Center. And then in 2014, the center was appointed by Ministry of Research and Technology as a Center of Excellence on Bioenergy until now. Then basically we have 4 main programs in this center. The first is research and development, and then the second is community development and also networking broaden, and then the last is product commercialization, because We were encouraged by Ministry of Research and Technology as Center of Excellence. We have to make the commercialization of the product of the research. Talking about the biorefinery, the main issue is how to utilize the biomass into high-value products such as energy, chemicals, and material without producing the waste. But the question is now raising, what kind of the biomass is the most potential that can be developed in Indonesia? Actually, in the first day of this webinar, Bu Febi from Ministry of Ministry of Energy and Mineral Resources, they mentioned that Indonesia has a lot of biomass. And actually last year, SBRC IPB University also conduct the research. This project was funded by Pertamina to select what kind of the biomass is the most potential to be developed as second generation of the biofuel. And then we collect all data of the biomass in Indonesia from the agricultural resources as well as from the plantation, from the paddy field, corn, sugarcane, cassava, palm oil, coconut, and so forth. And we also analyze using the analytical hierarchy process based on several criteria, based on the current utilization of the biomass, based on the energy content of the biomass and also the easiness of the collection of the biomass and of course the availability of the biomass. And then the answer as expected that the most promising biomass is palm oil in Indonesia. That's why in this presentation, I would like to briefly introduce the biorefinery concept of the palm oil as well as the microalgae because the microalgae is the third generation of the biomass. This slide shows the palm oil biorefinery developed at SBRC IPB University. So from the palm oil, we can generate the methyl ester by using the trans-esterification process. I believe BPPT also has a lot of the research on this methyl ester production. And then from this methyl ester compound, this compound can be converted further to methyl ester sulfonate. And also this methyl ester also can be converted to sucrose ester by sucrolysis. And this methyl ester also can be converted to diethanol amide using the amidation process. And then this methyl ester sulfonate in IPB University, we apply this compound as a surfactant for enhanced oil recovery. And also this surfactant also can be used as detergent, well cleaning agent, asphaltant deposit removal, wax dissolver, sludge breaker, or even personal care product. Meanwhile, the diethanol amide is an emulsifier that can be used as a personal care product, emulsifier of the pesticide, and also the oil spill dispersant. And then from the trans-esterification process, we can generate the byproduct, namely the crude glycerol with the content around 40%. This crude glycerol can be purified to generate the pure glycerol, and then this pure glycerol can be used as the water-based mud, cement grinding aid, or even coal dust suppressant to suppress the dust during the mining of the coal. And then this pure glycerol also can be observed, can be generated to obtain the glycerol ester using the esterification process. And then this product can be used the oil-based mud. Next, I would like to briefly introduce about the lab scale of the biodiesel production. So in IPB University, we produce the lab scale of biodiesel to the pilot scale into the 2 ton of liter of biodiesel. From the crude palm oil, the biodiesel can be produced by using the trans-esterification process. In this case, we use the potassium hydroxide as a catalyst because it's very cheap. Then the trans-esterification is occur at around 60 minutes. at 55 degrees Celsius. And as shown in this figure, the higher the methanol to oil ratio, the higher biodiesel yield. And then the optimum biodiesel could be achieved at the methanol to oil meal ratio around 7 to 1 within 60 minutes. So from this lab scale, we can use as the basis to make the pilot scale and then the commercial one. And then we also calculate the mass balance here. So from 200 gram of the CPO or crude palm oil, we can generate the 194.5 gram of the biodiesel, or we can calculate that the product yield is around 97%. And then currently, we also just finished conduct the project from PT Dharma Satya Nusantara, DSN, regarding the enzymatic biodiesel production using the crude palm oil as the feedstock. This is just the lab batch reactor to make the enzymatic biodiesel production. We also got support from the Novozyme from the Denmark. And then basically the trans-saccharification process of this biodiesel could be run at 40 degrees Celsius, 48 hours, and then the molar ratio of the CPO to methanol, and then the addition of the enzyme is 0.3%. Surprisingly, so this enzymatic biodiesel production could be employed for the wide range of the feedstock of the CPO, from the free fatty acid content 1.73 to 19.3%, we could achieve the same biodiesel yield around 93%. And then this is the mass balance of the enzymatic biodiesel process. The yield is around 93%. Comparing to the conventional, the previous slide, this yield is lower because the purification process is more complicated than the alkali catalyst trans-esterification. Next, this slide shows the supercritical biodiesel production. This supercritical biodiesel production was conducted in Hiroshima University. So as we may know that supercritical condition could be achieved at high temperature and high pressure. So in brief, the biodiesel, the first step is by sending the feedstock of oil and the solvents at the same time to the supercritical reactor. And then as shown in this figure, comparing to the conventional method, the supercritical biodiesel production has superiority in terms of the residence time. As shown in this figure, the supercritical methanol could be achieved within 10 minutes. Meanwhile, for the supercritical ethanol, could be achieved within 20 minutes. So compared to the conventional one, this technology is has the faster biodiesel production and no catalyst needed. And then we also implement the pilot plant of the biodiesel with the capacity of 200 liters per batch in PT Freeport. And then the feedstock used in this project is waste cooking oil, because PT Freeport has a lot of waste cooking oil. But the most challenging is we have to make addition of the pretreatment tank, because we have to filter the waste cooking oil, and then we have to remove the water of the waste cooking oil. And then until now, this biodiesel is still running well. And then this biodiesel is used for car and vehicles in PT Freeport. And then the next, right now, we are also scaling up the biodiesel production from 200 liters per batch to 2 tons per batch. This biodiesel plant is located in Gunung Putri in Bogor. And then this biodiesel is sent to PT Petrokimia Gresik, because we are now in collaboration with PT Petrokimia Gresik to generate the surfactant of the methyl ester sulfonate with the feedstock of the methyl ester. And then this slide shows you the fundamental process, how to synthesize the methyl ester sulfonate as a surfactant. So this mesh surfactant is synthesized from the methyl ester with the sulfur trioxide by using the sulfonation process. And then this sulfur trioxide actually is produced from the sulfur with the several steps, namely melting, burning, and oxidation. Then after we generate the methyl ester sulfonate acid. We can formulate this surfactant by adding the additive and co-surfactant. So this surfactant can ready to be used as enhanced oil recovery. This research was funded by Pertamina. And right now, we also in collaboration with PT Petrokimia Gresik to build the pilot plant of the methyl ester sulfonate surfactant for enhanced oil recovery. The installed capacity is around 2 tons, and then this pilot plant is under installation. Hopefully, by the end of this year, this reactor will run well. The application of this palm oil-based methyl ester sulfonate is for enhanced oil recovery and also for improved oil recovery. Another application of the methyl ester, actually we can generate another high value product, namely the ethanol amide, by reacting the methyl ester with the ethanol amide. And then the application, we already observed that the ethanol amide is effectively as an insecticide. And then this the commercial product of SBRC IPB University. We call it as LAMPEST. LAMPEST stands for lime pesticide. And then the ethanol amide also can be used as the emulsifier of the personal care product, such as the transparent soap, or even this is also can be used as emulsifier for the product of the home care. This is the product of SBRC IPB University. We call it as a GoCat. GoCat is the cat repellent. So it was made actually from the essential oil mixed with the water. As we may know that essential oil is not mixed well with the water, so we have to add the emulsifier. So in this case, we add the ethanol amide from the palm oil to generate the GoCat. And then another project we are running already is the purification process of the glycerol, because as we may know that the biorefinery concept is how we reduce the waste, or even we have to convert the waste into the high value product. And then this project was funded by LPDP, or Indonesia Endowment Fund. So the first step is we have to heat the crude glycerol and then addition of the phosphoric acid to remove the salt. And then after that, after filtered, we can get the pure glycerol around 80%. And then after vacuum distillation, we can generate the glycerol more than 95%. Then from this glycerol, pure glycerol, we can generate another high value chemicals products. One of them is the glycerol ester. This project also was funded by LPDP. So we add the glycerol and oleic acid from the palm oil with the addition of this catalyst. So we can generate the glycerol ester. This glycerol ester can be used as the anti-foaming as well as an additive or for oil-based mud, or AOBM. And then another application of the pure glycerol is we can synthesize, we call it MDAG. MDAG stands for monodiacyl glycerol. By reacting the pure glycerol with the PFAD. PFAD is palm fatty acid distillate, or the byproduct of the palm oil. Basically, this is the step of the how to synthesize the MDAG. And then the pure glycerol reacted with the PFAD, we can obtain the crude MDAG. And then after that, we can undergo the purification process using solvent extraction, crystallization, molecular distillation. So we can obtain the pure MDAG around 21%. And then this monodiacyl glycerol, the glycerol can be applied as anti-static agent of the plastic as shown in this figure. This is the polypropylene plastic, and then this polypropylene plus MDAG. As shown in the right figure, we can observe whether this MDAG or monodiacyl glycerol can be act as anti-static agent from the surface resistivity. Here, as shown in this figure, the surface resistivity of polypropylene alone is around 10 to the power of 11. Meanwhile, from the addition of the MDAG with the certain amount of the concentration, the surface resistivity was dropped into 10 to the power of 10, confirming that this monodiacyl glycerol acts as the antistatic agent. We also compare this MDAG with the commercial one, the modern HPM, and then the result is comparable. And then as shown in this figure, for the case of the MDAG 0.7%, the result even better compared to the commercial one. Overall, these products have been developed in SBRC IPB University, so we make or synthesize the surfactant from the palm oil, and the application is for enhanced oil recovery, stimulation agent, wax dissolver, and so forth. Last, I would like to briefly introduce about the microalgae biorefinery concept that have been developed in IPB University. As we may know, that microalgae also has a lot of the high value products such as the lipid, protein, carbohydrate, minerals, or even the vitamins. And then from the lipid fraction, we can generate the biodiesel from the crude oil by trans-esterification. Meanwhile, we also can generate the oleochemicals product from the extraction and purification process. And then from the protein fraction, we can generate the high value products such as amino acid, or even this protein can be used directly as a food. And then the residue of this process can be used as the biogas. And then the last, the carbohydrate fraction can be used as the biofuel such as the ethanol, butanol by using the fermentation process. And SBRCIPB University also has explored the potential microalgae species in Indonesia for biofuels. And we found that there are 13 species of microalgae in Indonesia waters containing potential lipid content. And then among them, the 4 main species, namely Nanochloropsis, has the highest lipid contents or crude oil contents around 24%. And then followed by Senadesmus around 22%, Chlorella 20%, and Dunalela around 15%. Then these flowcharts show you about the biodiesel production steps. So the first step is identification, isolation, and cultivation. This cultivation of microalgae, it takes around 10 to 14 days, depends on the species, environment, as well as the nutrient of the microalgae. And then harvesting, so we can generate the wet biomass. This wet biomass is then dried, and then extraction, so we can obtain the crude oil. This crude oil can be esterified and trans-esterified to generate the biodiesel. Lastly, we also observe the biopigment extraction from the microalgae. The step is almost the same. The first is cultivation and harvesting, so we can obtain the biomass of the microalgae, and then this biomass undergo the centrifuge process to generate the lipid-rich content. After that, this biomass undergoes the cell disruption and saponification to remove the chlorophyll and unwanted compounds. And then the last step is liquid extraction and solvent removal, so we can generate the carotenoids-rich extract. And then we analyze this pigment extract using HPLC. And then surprisingly, we can generate the pure pigment, namely astaxanthin, around 99% from the species of microalgae. As we may know that this pigment, biopigment, is so expensive, the price is around 200,000 to 500,000 rupiah per 10 gram. That's all my presentation. Thank you very much for your kind attention.
Okay, thank you very much, Mr. Obie Farobie, for the nice presentations. Actually, you have still 10 minutes, yeah. But yeah, we can discuss later. As moderator, I am sorry if I have mistaken during webinar. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih Mr. Hiroshi KAKESHITA dan Dr. Obie Farobie atas presentasinya sangat insightful dan bermanfaat. Terima kasih juga kepada Bapak Dr. Hensa Putra karena sudah memandu sesi tanya jawab dengan sangat interaktif dan para pembicara yang sudah menjawab pertanyaan yang sudah diajukan juga. Nah, saat ini kami akan menekankan Introduction of Japan's Public Support Scheme, GST Support in International Joint Research and Talent Mobility, yang akan dibawakan oleh Miss Emi KANEKO as Director, Singapore Office, Japan Science and Technology Agency, GST. Kepada
質問に答えたスピーカーや質疑応答のセッションを盛り上げていただきありがとうございました。続きましては、金子様により日本の公的支援制度の導入、国際共同研究と人材モビリティにおける GST のサポートについてのプレゼンテーションを行います。金子様は国立研究開発法人科学技術振興機構シンガポール事務所の所長として務めています。それでは金子様どうぞ。
技術振興機構シンガポール事務所の金子と申します。この度は私どもの事業説明にお時間いただき誠にありがとうございます。
Terima kasih. Perkenalkan, nama saya Kaneko dari Japan Science and Technology Agency atau GST yang berkantor di Singapura. Terima kasih telah meluangkan waktunya untuk saya bisa menjelaskan tentang GST.
今日の発表内容はこの GST のサポート、国際共同研究と人材、交流事業についてというものです。
Untuk hari ini, saya akan memperkenalkan tentang GST.
科学技術振興機構のことを略称で GST と呼んでいますが、GST がどういう組織であるか一言で申し上げると、ファンディングエージェンシーです。ファンディングエージェンシーとは研究資金を助成または補助する機関のことです。
Japan Science and Technology Agency yang disingkat dengan GST adalah lembaga penyandang dana, lembaga pendanaan dan lembaga yang mensubsidi atau mensubsidi pendanaan penelitian.
日本の代表的なファンディングエージェンシーはここにある4つですけれども、メドさんもその中の一つです。で、大学や研究機関、企業に対してそれぞれ異なる視点から資金助成をしています。JST は医学以外の分野における基礎研究や産学官連携に対する支援を行っています。
Ada 4 perwakilan lembaga pendanaan di Jepang yang terdaftar, NEDO menjadi salah satunya, tetapi kami mensubsidi universitas, lembaga penelitian, dan perusahaan dari perspektif yang berbeda. GST memberikan dukungan untuk penelitian dasar dan kolaborasi industri, akademisi, pemerintah di bidang selain kedokteran.
GST は国連の SDGs は非常に重要なものであると考えておりまして、その達成に貢献することをプライオリティとして掲げています。
GST menganggap UN SDGs sangat penting dan memprioritaskan kontribusi untuk mencapainya.
GST がインドネシアをはじめとする ASEAN 加盟国対象に運営しているプログラムが3つあり、E アジア JRP、サトレップス、バクラサイエンスプログラムです。まず E アジア JRP のご説明をします。
Ada 3 program GST yang beroperasi di Indonesia dan negara anggota ASEAN lainnya. Yang pertama E Asia JRP, kemudian SATREPS, dan Sakura Science Program. Pertama saya akan menjelaskan dulu mengenai E Asia JRP.
E アジア JRP とは東アジアサミット3カ国を対象に運営されている共同研究プログラムです。東アジアサミット3カ国とは ASEAN10 カ国、日本、中国、韓国、オーストラリア、ニュージーランド、アメリカ、ロシア、インドの計15カ国です。
E Asia JRP adalah program penelitian bersama yang dioperasikan untuk negara-negara peserta KTT Asia Timur. Negara peserta KTT Asia Timur adalah 10 negara ASEAN, yaitu Jepang, Cina, Korea Selatan, Australia, Selandia Baru, Amerika Serikat, Rusia, dan India dengan total 15 negara.
これらの国で3カ国以上で国際共同研究プロジェクトを公募して評価の上、採択になったものに対し研究資金を助成しています。対象となる研究分野はこのスライドの右下に記載のあるものです。 2012年以降、毎年研究提案の公募を行い、今まで約50件の支援を行いました。
Di negara-negara ini, lebih dari 3 negara telah meminta proyek penelitian bersama internasional, mengevaluasinya, mensubsidi dana penelitian untuk diadopsi. Bidang penelitian yang terdaftar bisa dilihat di sudut kanan bawah slide ini. Setiap tahun, sejak 2012, kami telah mengumpulkan proposal penelitian dan sejauh ini telah memberikan sekitar 50 support.
アジアの参加対象国は先ほど申し上げた東アジアサミット参加国ですが、実際に加盟してくれているのは薄い水色が背景になっているこの14カ国です。また対象国ではないけれどもゲストとして参加が認められている国がスリランカです。
Negara target e-Asia adalah 15 negara yang saya sebutkan sebelumnya. Tetapi sebenarnya anggota adalah 14 negara yang berwarna biru muda. Selain itu, Sri Lanka bukan negara target, tetapi diperbolehkan untuk berpartisipasi sebagai tamu.
日本の研究者は JST またはもう一つのファンディングエージェンシーである AMED から、インドネシアの研究者はリステックグリーンから研究資金を受け取ることになります。
Peneliti di Jepang akan menerima dana penelitian dari GST atau AMED, lembaga pendanaan lainnya, dan peneliti Indonesia akan menerima dana penelitian dari Ristek Green.
今週火曜日の12月15日からまた研究提案の公募を開始しましたが、インドネシアと日本の研究者が応募できるのは、マテリアルズ・インフォマティクス、海洋科学および医学分野です。公募の詳細は e アジアのホームページでご確認ください。e アジア JRP とウェブで検索していただくともっと情報が出てきます。
Kami mulai mengumpulkan proposal penelitian lagi mulai tanggal 15 Desember kemarin. Peneliti Indonesia dan Jepang dapat mengajukan permohonan untuk bidang material informatika, ilmu kelautan, bidang medis. Silakan periksa situs web e-Asia untuk detail tentang panggilan terbuka untuk peserta. Anda dapat menemukan informasi lebih lanjut dengan mencari di web, ketik saja e-Asia JRP.
e アジアは3カ国以上での共同研究を促進していますが、このサトレプスというプログラムは基本的に日本と相手国という2カ国での共同研究を支援するものです。2008年以降、52カ国と協力して約160のプロジェクトを支援しました。対象となる研究分野はこのスライドの右下に書いているものです。
e-Asia mempromosikan pertukaran penelitian di lebih dari 3 negara. Tetapi program yang disebut SATREPS ini pada dasarnya mendukung penelitian bersama di 2 negara, Jepang dan negara mitra. Sejak 2008, kami telah bekerja sama dengan 52 negara untuk mendukung sekitar 160 proyek. Bidang penelitian sasaran adalah yang tertulis di kanan bawah slide ini.
日本の研究者は JST またはもう一つのファンディングエージェンシーの AMED から、インドネシアの研究者は JICA から研究資金を受け取って、この2カ国の間で共同研究プロジェクトを実施していただくことになります。詳しくはサトレックスと検索していただければ詳細情報が出てくるのでご覧ください。
Peneliti Jepang akan menerima dana penelitian dari GST atau AMED, lembaga pendanaan lain, dan peneliti Indonesia akan menerima dana penelitian dari JICA Jepang untuk melaksanakan proyek penelitian bersama antar 2 negara. Untuk informasi lebih lanjut, silakan ketik SATREPS.
最後に桜サイエンスプログラムです。これはインドネシアを含む ASEAN 加盟国から高校生以上40歳以下の若手人材を JST が経費負担する形で日本に招聘し、日本の最先端の科学技術に触れていただくというものです。
Terakhir, program Sakura Science. Ini untuk mengundang sumber daya manusia muda dari siswa sekolah menengah atas hingga 40 tahun untuk berkunjung ke Jepang dari negara-negara anggota ASEAN termasuk Indonesia dengan menggunakan biaya dari GST. untuk merasakan sains dan teknologi mutakhir di Jepang.
JST がほぼ一年中研究交流計画を公募していますので、日本の大学や研究機関、企業から応募していただき、採択になればインドネシアの協力先と連携して研究交流計画を実施していただくことになります。
GST meminta rencana pertukaran penelitian hampir sepanjang tahun. Jadi kami meminta universitas, lembaga penelitian, dan perusahaan Jepang untuk mendaftar. Selanjutnya, kami akan merencanakan pertukaran penelitian bekerja sama dengan mitra yang ada di Indonesia.
詳しくは QR コード読み取りの上、桜サイエンスプログラムのホームページをチェックしてみてください。
Untuk detailnya, silahkan membaca kode QR yang tersedia atau membuka situs web program Sains Sakura.
以上、簡単ですが JST のプログラムをご紹介させていただきました。ご清聴ありがとうございました。
Demikianlah penjelasan singkat saya mengenai program-program yang dijalankan oleh JST. Terima kasih atas perhatian Anda.
Baik. Terima kasih Miss Emi KANEKO. Baiklah Bapak Ibu, kita telah sampai di penghujung acara webinar kita mulai tanggal 14 Desember 2020 hingga 17 Desember 2020 hari ini. Sebelum saya menutup acara ini, saya akan mengundang Bapak Dr. Hammam Riza MSc sebagai Chairman of the Agency of the Assessment and Application of Technology Indonesia. Kepada Bapak Dr. Hammam Riza MSc, kami persilahkan untuk memberikan closing remarks.
最後になりますが、インドネシア評価応用庁 BPPT の会長、ハマムリザ様により閉会スピーチがあります。それではハマムリザ様、お願いします。
Bismillahirrahmanirrahim. Rabbi sari sadri wa yasir li amri wahlul 'uqdatam min lisani yafqahu qawli. Tawakkaltu 'ala Allah, la haula wala quwata illa billahil azim. Yang saya hormati Chief Representative NEDO Asia. Greetings to Ibu Yurugi Yoshiko. Greetings to Pak Dirjen EBTKE, Pak Dadan Kusdiana, Ketua Masyarakat Energi Biomasa Pak Joko Winarno, Deputi Kepala BPPT, Bidang Teknologi Informasi, Energi dan Material, Bu Enia, juga kalau hadir di sini Pak Deputi TAB, Pak Sony, para panelis dan para narasumber yang mungkin telah mengikuti acara ini sejak dari 2 hari yang lalu ya, ini hari ketiga setahu saya seluruhnya. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi dan salam sejahtera untuk kita semua. Shalom, Om Swastiastu, Nama Budaya, salam kebajikan. Kita panjatkan puji syukur kehadirat Allah Subhanahu wa taala atas izinnya pada ketiga hari yang kita laksanakan ini, kita menyelenggarakan acara Indonesia Biorefinery Future Outlook and Introduction of Technical Solution yang atas kerjasama BPPT bersama NEDO dari tanggal 14 hingga hari ini tanggal 17 Desember. Jadi seluruhnya ada 4 hari malah ini. Ya. Bapak Ibu, para hadirin dan peserta acara webinar yang saya muliakan, sebagai bagian dari kerjasama berdasarkan nota kesepakatan antara BPPT dan NEDO yang telah terjalin sejak tahun 2000. So we had our cooperation with NEDO and BPPT since 2000, the year 2000, and it is very fortunate that we have pushed forward the use of research and development, disseminations of technology, especially in the renewable energy, as well as the use of this technology in the industry. So this webinar is becoming to the end. Terima kasih kita telah berhasil menyelenggarakan acara webinar ini. yang mana tujuan dari kita mengadakan webinar ini adalah untuk menjajaki seluruh terobosan-terobosan inovasi khususnya di dalam topik biorefinery. Selama webinar telah dibahas berbagai macam tema mulai dari kebijakan pemerintah dan tren terbaru bidang biomasa dengan narasumber dari SDM, dari BPPT, dari MEBI ya, Masyarakat Biomasa Indonesia. Selain itu juga telah dibahas tentang pengenalan solusi biorefinery terbaru, biogas, perkebunan berkelanjutan, serta teknologi yang bernilai tambah tinggi dengan pembicara dari Jepang dan Indonesia. Saya yakin bahwa pembicaraan dari hari pertama hingga hari ini betul-betul telah mengungkit semua isu-isu yang terkait dengan misalnya kebijakan energi biomasa di Indonesia, ya, yang telah disampaikan oleh narasumber. Kemudian teknologi pemanfaatan biomasa, ya, ini pasti dari para perekayasa, ahli pakar-pakar dari BPPT. Kemudian ada juga gasifikasi biomasa dari Clean Power Indonesia. Di hari kedua dan ketiga itu juga menampilkan pembicara dari berbagai pihak, dari Indonesia maupun Jepang, dari Osaka Gas yang memaparkan tentang original advanced biogas upgrading and business activities in Indonesia, dan sebagai partner dari Indonesia untuk memaparkan tentang biogas dari palm oil melfluent pome for electricity and others. Hari ketiga juga saya kira topiknya juga menarik mengenai oil palm seed propagation technology dan kemudian dari pihak Jepang juga telah memaparkan tentang biotechnology for sustainable environment, maximizing the capability of photosynthesis in Southeast Asia dari Chitose ya, bioevolution. Dan tadi mungkin kalau mohon koreksi kalau saya salah. Tadi telah dibahas ya Pak Sumbogo ya tentang biomass Saccharification technology for producing high value added substances oleh Dr. KAKESHITA Hiroshi, Senior Manager dari Cow Operation, dan Bio-based Chemical from Biomass oleh Dr. Obie Farobie dari IPB. Jadi memang sudah sangat lengkap acara pembahasan dan diskusi di webinar ini. Dan saya menyambut baik pelaksanaan acara ini. Mohon maaf saya tidak bisa hadir dari kesempatan yang pertama karena BPPT juga melaksanakan praraker 2021 ya di hari awal tanggal 14 dan 15. Dan saya berharap dengan kehadiran kita semua segala sesuatunya yang menyangkut biorefinery antara Indonesia dan Jepang itu akan menguatkan kolaborasi sehingga dapat berkontribusi di dalam pemanfaatan biomasa di Indonesia. So I thank you for NEDO. Saya mengucapkan banyak terima kasih kepada NEDO, kepada BPPT, seluruh peserta dan seluruh pembicara, para narasumber, moderator, dan panitia. Sehingga seluruh rangkaian acara ini dapat berjalan dengan lancar. Untuk itu, izinkan saya dengan mengucapkan syukur alhamdulillahirrabbilalamin, maka webinar Indonesia Biorefinery Future Outlook and Introduction of Technical Solutions dengan ini saya nyatakan ditutup. Demikian yang dapat saya sampaikan. Wallahu muwaffiq ila waqit tarik. Billahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Om Santi Santi Santi. Namo Buddhaya. Salam kebajikan. Terima kasih. Terima kasih semua. Ya.
はい、少し、日本語に通訳させていただきます。ネドバンコク事務所のゆるぎ所長、エネルギー鉱物省新再生可能エネルギー省エネルギー総局長のダダン局長、インドネシアバイオマスエネルギー協会のジョコ会長、 技術評価応用長次官のエニア様、技術評価応用長次官のソニー様、パネリスト、講演者、参加者の皆様、こんにちは。おかげさまで BPPT ネド共同で開催されたインドネシアにおけるバイオリファイナリーの将来、展望と最新技術紹介のウェビナーは14日から17日までこの4日間無事に終了となりました。参加者の皆様、BPPT と NEDO は2000年に包括的協力覚書を締結以降、エネルギー環境技術などさまざまな分野で協力関係を構築してきました。活動の一環として本ウェビナーを開催をいたしました。本ウェビナーでは、インドネシアにおけるバイオリファイナリーに関する政府政策や技術開発の最新動向、さらに日本企業の有する最新技術についてプレゼンテーションがありました。インドネシアおよび日本のバイオマス関連事業、それぞれの専門者から有用なお話が聞けたと思います。最終日は、そして、1日目はインドネシアにおけるバイオマス政策および最新取り組み動向についてのプレゼンテーションがありました。2日目から4日目はインドネシアおよび日本それぞれのバイオリファイナリー技術の紹介がありました。3日目は技術評価応用書からパームオイルシード電波技術の説明があり、そして日本側から千歳バイオエボリューションの福井様により、持続可能な環境のためのバイオテクノロジーについての講演がありました。最終日はカオコーポレーションの掛下様により、高付加価値物質生産ためのバイオマス投下技術の話がありました。そしてボーゴル農科大学のオビ様により、バイオマスからのバイオベースの化学物質についての講演がありました。本ウェビナーはインドネシアと日本のバイオリファイナリーに関する技術、トレンド、政策の分野で情報共有になれたと思います。インドネシアのバイオマス利用の発展に貢献するさまざまなバイオリファイナリー技術を導入することにより、日本とインドネシアの新たな共同事業が生まれることを願っています。NEDO、BPPT、講演者、モデレーター、オーガナイザー、このウェビナーを円滑に準備や成功させるため、すべての関係者に感謝をいたします。ありがとうございました。これでこのウェビナーを閉会をいたします。
Baiklah Bapak Ibu, dengan berakhirnya closing remarks dari Bapak Dr. Hammam Riza MSc, maka berakhir juga acara rangkaian webinar kita. Bagi Bapak Ibu yang ingin mendapatkan sertifikat, mohon dapat mengisi link evaluasi tertera pada layar.
はい、証明書を取得したい方は、評価リンクと QR コードが画面に表示されるところにご記入をお願いします。
Bagi Bapak Ibu yang bersedia menjawab kuesioner, akan diberikan materi yang memuat resume teknologi dan dari kontak 3 perusahaan Jepang yang memberikan presentasi di hari kedua, ketiga, dan keempat, ditambah lagi materi yang ringkas yang berisi informasi skema support dan kontak 7 lembaga publik Jepang yang memberikan informasi dalam webinar ini. Oleh karena itu, mohon kerjasamanya untuk menjawab kuesioner.
積極的にアンケートをご記入の方に2日目から4日目のプレゼンテーション資料や日本企業の3社の連絡先を提供させていただきます。そしてサポートスキームや7つの公的機関の連絡先も提供しますので、アンケートのご協力をお願いします。
Terima kasih Bapak dan Ibu atas partisipasi hari ini. Mohon maaf bila selama memandu acara terdapat hal-hal yang kurang berkenan. Mohon kita bisa bertemu kembali di webinar selanjutnya. Selamat siang dan selamat beraktivitas.
本日ウェビナーにご参加いただき誠にありがとうございました。イベント中何か不備がございましたらお許しください。次のウェビナーに会えるのを楽しみにしています。皆さん、本日ありがとうございました。